Hello everyone, welcome to today's class. We will look at a very popular topic in physics titled vertical motion and gravity. Let's see what this topic is all about. Alright, so what do we mean by vertical motion and gravity? This simply refers to the movement of a body under the sole influence of acceleration to gravity, that is G, or the acceleration of free fall. So you see, in real life, vertical motion doesn't really exist because it's an example of projectile motion, but in this case, the horizontal component of the velocity is zero. Now, vertical motion obeys Newton's laws of motion, Newton's equations of motion very precisely. Now, there is a simple trick to know when dealing with questions under vertical motion. For upward motion, since the body moves in a direction opposite to that of the acceleration of free fall, we negate the value of g. But for downward motion, where the velocity of the body is in the same direction as that of g, we assign g to be a positive value. So that determines your equations either becoming negative or becoming positive. So now we will look at the equations for two different cases, that is for upward motion and downward motion. Now I can see for upward motion, acceleration replaced by a is equal to minus g, as we explained in the previous slide. So the first equation becomes v equals u minus gt. Second one becomes v squared equals u squared minus 2gx, and the third one s equals ut minus half gt squared, where we know that u is initial velocity, v is final velocity, s is the distance covered, and t is the time. Now for downward motion, acceleration equals positive g, since the direction of motion and the acceleration of gravity are in the same direction. Now the first equation becomes v equals u plus gt. We have the second one becoming v squared equals u squared plus 2gs, and then we have s being equal to ut plus half gt squared. Now we have what we call time of flight. Time of flight simply refers to the total time spent by the body in air before touching the ground. In other words, it's the time that it takes to move up and come down. And we also have what we call maximum height, written as h subscript max. Now it is just the distance attained by the body with respect to the ground, the emphasis with respect to the ground. So we can have the body airborne or from a height, but the maximum height is the summation of the distance covered whilst airborne and that of a tower if the need be. Now let's take a look at the first question, which reads as: a stone is dropped from a tower. It takes 8 seconds to reach the ground. Calculate the height of the tower. And the second part, calculate the final velocity of the stone. G, as usual, will be taken as 10 meters per second squared. So we have our diagram here. This is the tower with height h, and then also this arrow here showing that the body is moving down as it just dropped down. Now let's bring out the parameters. Just take a note that when the body is dropped, the initial velocity is 0, hence u equals 0, and we have t, time, to be 8 seconds. So we have to find h, which is unknown, and also v, which is unknown. We can choose to find v first, that is thereby solving the second part first. So we use the first equation, which is v equals u plus gt. Now it's plus because the body is moving down. This is a downward motion, so it's supposed to be plus. So we put in the parameters. U is 0, g is 10, t2 is 8. So we get v equals 80 meters per second. Hence this is the final velocity of the stone. Now also go to find the height of the tower using the equation v squared equals u squared plus 2gs. So v becomes what we have just found. So we have 80 squared equals 0 squared plus 2 into 10 and then s. So we have you replace s with h, since it's just distance, but that means the height. So we get h being equal to 320 meters. Hence the height of the tower is 320 meters. Now the second question reads as: a man stands at the top of a 200-meter high tower and throws a ball vertically upwards with a velocity of 20 meters per second. We're supposed to find I and I. Alright, so as usual, okay, our diagram is shown over here, captured nicely, where the tower is over here 200 meters, and then we have the trajectory. This just showing the part of the body, or the stone, or the body. So we have A shown here, point B, and we also have the point C and then point D. Point D is with respect to the ground. So you can see that the body moves along path A to B, and then B to C, and then C to D. Okay, from the question, parameters here, u equals 20 written over here. Now at the maximum height, velocity equals 0, since the body stops momentarily before coming down. So at least we have v equals 0, and we'll use the equation v squared equals u squared minus 2gs. This is for the part AB, that's the upward motion, hence acceleration is negative g, and then we replace the s with h. So putting your v being 0 and u being 20, rearranging, we get h is equal to u squared over 2g. Put in the parameters and we get h equals 20 meters. Hence this is the height covered in air, that's what's airborne. Hence the maximum height becomes the height covered in air plus the height of the tower. That gives us 220 meters. Okay, the second part of the question asks us to find the time of flight. In simple terms, it should be the time taken to cover the part AB plus that for BC and that for part CD. Now along the part AB, where B is at the maximum height, we have V equals 0 in the previous slide. So we use the first equation, which is V equals U minus GT subscript AB, to show that we are on that part. Now V is 0, U is 20, G is 10, and minus sign was an upward motion for that part. So we arrange, or you get TAB equals what? 2 seconds. Now remember that point A and point C are on the same level. In physics, when 2 points on the same level, they have many things in common. Example, the velocities at that level are the same, and also the time taken to move from A to B is the same time taken to move from B to C. So I can say TAB equals TBC equals 2 seconds. So we are just left to find the time taken on the part CD, which is TCD. For that, we assume the body is at level C. So for that level, the distance downwards is the height of the tower. That is S equals 200 and U equals 20. Remember that U is the velocity that it was thrown up, which is at level A, but level C2 has the same properties. So we use the equation S equals UT plus half GT squared, plus, because that is a downward motion. Now we put in the parameters, we get 200 equals 20t plus half 10t squared, and rearrange, or we get 5t squared plus 20t minus 200 equals 0. So this becomes a quadratic equation for which we will use the almighty formula to solve it. Now the almighty formula we know is given as t equals minus b plus or minus square root of b squared minus 4ac all over 2a. Hope you remember that. So our a is 5 from the equation, our b2 is 20, and then our c is minus 200. So just put them inside. We have tcd equals 4.633 seconds, or negative 8.633 seconds. Now remember that time cannot be negative, hence we go for the positive value, which is tcd equals 4.633 seconds. Hence the time of flight will be equal to 2 plus 2 plus 4.633 equals what? 8.633 seconds. That's good. Hope you understand it. And the third part here is supposed to find the total distance covered. As usual, that way can be SAB plus SBC plus SCD, where SAB will be equal to SBC, which is the height covered whilst airborne. That is the height attained at level B, which we found already to be 20 in the previous slide. and now SCD, it's in parallel to the tower, hence SCD becomes the height of the tower. It's about 200 meters, so no need for any further calculations. Replace the equation to become S equals 2h plus SCD. The 2h here is coming from SAB plus SBC. Then we get S equals 2 into 20, then plus 200. That gives us S equals 240 meters. And the total distance covered is 240 meters. Hope we are all on the same page. Now remember to comment, like, share and subscribe. See you in my next class. Thank you.